Hello class, this is a video tutorial on multi-stage probability part 2, and in this video we'll be looking at weighted trees or weighted branches. In the previous example using probability trees, each outcome was equally likely. However, when outcomes are not equal, we have to include weighted branches in the probability tree. So let's get straight into an example here. A bag contains 3 red and 2 blue balls. A ball is randomly selected, returned, and another is selected. Create a probability tree modeling the 2 ball selections. So as you can see, because 3 is more likely than the 2 blue balls, we have to use some sort of way to distinguish that red is more likely than the blue. We do this by, first we draw this as we would normally. So we put red and blue, and then red and blue, like so. Same goes for this, red and blue. And as you can see, so far, it's the exact same as we normally would for the probability tree. There we have it. So this is ball 1. So let's do this in a different color. This is ball 1 and ball 2. But this tree diagram that we've drawn indicates that red and blue are equally likely to occur as one another. It's like saying that there is 1 red and 1 blue ball in this bag. But as you can see that there are 3 red and 2 blue balls. Well, to distinguish between the two, we write the probability of selecting a red ball first. Well, the probability of selecting a red ball is 3, because there are 3 red balls, out of a total of 5. So the probability going to this path is 3 out of 5. As for going down this path, the blue ball, it says that there are 2 blue balls in the bag. So 2 out of the 5. So we've put a weight onto the branch to indicate that it is not the same in probability of red and blue. We do the same for this one. Because we've put the ball back in, the probability of selecting a red again is 3 out of 5, and selecting a blue is 2 out of 5. We complete this for this as well. 3 out of 5, 2 out of 5. And just to finish this off, we can write down red, 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 blue, blue, red, and blue, blue. And that is a completed probability tree. There's a few notes that I wanted you to not look at until now. Now, take note that each branch probability must add to 1. So, in each layer, 3 out of 5 plus 2 out of 5 is 1 whole. Same goes for this one particular branch. 3 out of 5 plus 2 out of 5. Together, these make 1 whole. And the same for these two. The next note that we should just remember is that whenever we do these next calculations that we're about to do, we multiply going through the branches, so horizontally, so going this way we multiply, and once we've multiplied what we need, we add vertically. Let's demonstrate this in this first example here. Calculate the probability of selecting 2 red balls. So we can write this as probability of red, red is equal to, well, since we need to arrive to red, red, to get to here, we multiply horizontally, following the path we need to take to get here. So red, red. The numbers that we took to get here are 3 out of 5 times 3 out of 5. So that's 3 out of 5 times 3 out of 5. Straight into our calculator. We get 0.36, but let's leave this as a fraction. That's 9 out of 25. What's the probability of getting a red and a blue ball? Well, notice how it said just a red and blue ball, not specifying whether it's red and blue, then a blue and then red. So we could get probability of red, blue, or the probability of blue and then red. So let's find both of them and let's add. So red, blue, that's 3 out of 5 times 2 out of 5. I'll do it here. So 3 out of 5 times 2 out of 5, that's 6 out of 25. Just multiplying 3 out of 5, this path, times 2 out of 5, this path. So there's our total there. And the probability of blue, red, well, same deal. We follow the path. Blue, red, that's 2 out of 5 times 3 out of 5. Multiplying the 2, that's 6 out of 25. That's applying this rule here. We're multiplying horizontally, going through this way. And now that we have it, we're going to add what we need vertically. So red, blue is 6 out of 25 plus 6 out of 25 blue, red. You can put that in straight into your calculator. That'll be 12 out of 25. One last example, a blue and red in that order. In this case, it's being very specific in that we must use blue and red only in that order. So this is probability of blue and then red, which we have already calculated. Blue and then red, which was 6 out of 25. So I hope that gave you an insight into creating weighted probability trees. I'll be doing another example of this later on, or in the next video. You can go ahead, take a screenshot of this if you'd like, but I hope to see you in that example then. Best of luck.